So some of you got a little bit confused with the internal resistance of a battery and how to actually carry out the experiment on Monday. Therefore, I thought I'd show you with this animation what you will be doing in practice. So first of all, we need our cell, what they call battery here, and we want to measure the current that flows out of that cell, and we want to measure the potential difference across the terminals of the cell. So here I have this cell and it currently has 9 volts of potential difference across here. So let's see what happens if I connect a resistor, and when I measure the current that flows, what I get here. So I'm setting this up. This is what you will be doing in your investigation. And this resistor, even though it looks like an ordinary resistor, allows me on this animation to vary its resistance. So you see here I'm getting a voltage of 9 volt and a current of 0.9 amps. I can actually change the internal resistance, what they call battery resistance. We call it internal resistance, and I'm going to go for a value of 2 ohms. You see, as I did this, I now have more resistance in my circuit. So overall, due to the internal resistance that is now 2 ohms, I do get a lower current. It's no longer 0.9 amps, but it's 0.75 amps. And the potential difference across my terminals of my cell is also has dropped from 9.0 volts to 7.5 volts. So I want to record this actually and then plot a graph of this. So for my current, I have here 0.75 amps and my potential difference was 7.5. So I'm going to change now the resistance. You can do this by putting several resistors in series, or if you use a variable resistor, you can change things that way. And I'm going to increase it a bit, and then I'm also going to decrease it. Typically, you would be either increasing it or decreasing it. I'm going to do a bit of both in this case here. I'll go for 20 ohms. That gives me a voltage of 8.18 and a current of 0.41. 0.41 is my current, and 8. Was that right? 8.18 volts. So what I'm changing here with this resistance is effectively the current. I'm actually not recording the resistance, I'm just recording the current because that's what interests me. And in fact, I could also do it this way, that I would change it to some nicer values like 0.4, and I got here 8.2 volts, and let's go for 0.3 amps and 8.4 ohms, 8.4 volts rather, and maybe a few more. Let's just see, 0.2 amps I get for 8.6 volts, and maybe 0.1, 8.8. Okay, and I can also go in the other direction. So I had started off with 10. I now want to go for 0.8. I can't even do. That's not going to work out with this animation. Let's see what I can do. 0.9 amps makes 8. What was it? 7.2, and 0.95 gives me 7.11. Okay, and that should actually do for now. What I want to do is plot a graph and have a look at what this looks like. So you see this looks rather familiar after what you've seen in class. Here's my terminal potential difference in volts and my current in amps. And if I now go on customize series, I want a line of best fit in there. It's called a trend line with a label using the equation. This tells me that my graph, my line of best fit here, which is pretty much perfect because I've used an animation and it doesn't look quite as rough as what I showed you in class, has minus 1.99 times the current. We said that the negative gradient was actually equal to negative R, and R being the internal resistance. We had set this here to 2.0 ohms, so my line of best fit with negative 1.99 is quite close to 2.0 ohms. So there we go. This should give you a bit of an idea of how you would set this up next week. And I'll be here, of course, and help you if you run into any troubles. I would recommend that you verify this for yourself. You can try this here with a different value of resistance, and you should actually get a steeper line than for those other values that you get. Good luck, and we'll see you on Monday or Wednesday, depending on which group you're in. Bye.